All right, before we talk about even and odd functions, let's go over the answers to finding the asymptotes to these three equations. So our first equation was x squared plus 2 over x squared minus 1. And I personally think it's easier to find the horizontal asymptote first. So I'm going to look at my powers. Bottom equals top. So what am I going to use? Betsy. So I'm going to use lead coefficient. So 1 over 1, which means y equals 1 is my horizontal asymptote. You can use HA for horizontal asymptote. Don't have to write out. Those are two big long words. Cool? Cool. And then VA for us in math. No, it's not Virginia. It's vertical asymptote. All right, to find the vertical asymptote, I need to factor the bottom. So that's going to be x plus 1 and x minus 1. Is there any chance when I factor the top that I'll get one of these factors up top? No, so I'm not going to spend my time doing it. So x plus 1 equals 0, x minus 1 equals 0. My vertical asymptotes are x equals -1 and 1. Cool? Question. Yes. Okay, it includes both. Everyone good? We okay with that? Do we understand why the warm-up was factoring today? Okay, all right, moving on. Okay, the next example. All right, now this is a cubic, and let's start with the easiest. Let's find the horizontal asymptote. Okay, which type is this? Bigger on the bottom, so it's a bob. So y equals 0. That's my horizontal asymptote. To find my vertical, I'm going to factor this. It's x minus 2, x minus 2, x minus 2. Okay, when I factor the top, is it going to be an x minus 2? No, but just to prove to you, it's going to be 4x minus 1, so nothing repeats, correct? Okay, so my vertical asymptote is x equals 2. Remember, it's opposite sign because this is a factor. This is the solution, the root, the 0, the x-intercept. It's got like several aliases. Alii. I always mess that up, the plural of a certain thing. Good? All right. And the last example I had you try. Okay, so we have x minus 1 and x. So horizontal asymptote, y equals 1 because the powers are equal and 1 over 1 is 1. Okay, what is my only root or 0 for the denominator? X equals 0. You set the factor equal to 0 and solve. X equals 0, there's nothing to solve. Yes? I get them every time with that one. That's why I chose it. Are we good? Yes? Okay. Now, backtrack to last week. Oh, sorry. I forgot. We got one more example. So, let's do this one together. Actually, I'm going to give you 30 seconds. Find me the vertical and horizontal. Great. So let's look at this example. First, horizontal asymptote. The powers are the same, so it's going to be 1 over 1, so y equals 1. And no, your horizontal asymptote is not always going to be 1. It's just I was too lazy to put a lead coefficient up there. Okay, so now I'm going to factor the bottom. X minus 2, x plus 2. Yes? Okay, I need to check the top. What's the top going to be? X plus 3. X plus 2. Whoa, red flag. Red flag, what do you notice? They are the same. So they are not going to produce a vertical asymptote. They're going to produce a hole. I have a hole at x equals 2 and a vertical asymptote at, I'm sorry, that's wrong. A hole at what? -2, because that's a factor. I have to solve it. And a vertical asymptote at x equals 2. You see why I picked that example? Because these are factors. I have to set them equal to 0 to get the root or the whole. You with me? Okay. Good. All right. Let's move on. Okay. So last week we talked about even and odd. What can you tell me? How do I know if something is even by looking at the picture? It's symmetrical to y-axis. Great. Now you got to dig into your brains and go back to geometry class. If I want to reflect it over the y-axis, how do I show that? Yes. Excellent. Negative xy. If I want to reflect over y, I flip my x. If I want to reflect over my x, I flip my y. Okay, great. This is going to be important. Okay? So if I gave you an ordered pair and I said it was an even graph, you could give me another ordered pair. That would be on that graph. Yes? Okay, let's talk about odd. So, odd, when I look at the graph, it's what? Reflected over the x-axis. Also, a rotation of 180 degrees or a double reflection. So, what would that look like? Negative x and negative y. Okay? So that's if I gave you some ordered pairs and I asked you for other ordered pairs to make the function even or odd. Okay? Now, when I did notes, I talked about f of x equaling a negative f of x and f of negative x still equaling f of x. You with me? You remember doing that? It's called proving that a function is even or odd algebraically. So we are going to practice that. And your homework will be based on that and asymptotes. So looking at this first problem, f of a negative x means every x is going to be replaced by negative x. Excellent. So let's do this example. So we have a negative x. Always use parentheses, please. To the third power plus 2x minus 9. Okay. What is negative x to the third power? Oh, sorry, this should also be a negative x. Wow. Okay. So it's going to be negative x to the third. This is going to be minus 2x, yes? And then a minus 9. Now, I want you to look at the original and look at the bottom. If it is an odd function, then everything would have to flip. Did all of my signs flip? No, this one right here messed me up. Therefore, did everything stay the same? No. If they didn't all flip signs and they're not all the same, it is neither odd nor even. Okay? If every sign flips, it is odd. If every sign stays the same, it is even. Even Steven. Cool? All right. Can I change the screen? Very simple. You just replace your x with a negative x. But the parentheses are important, especially when it's even power. Okay, because you want to take the power to the sign. Yes, sir. No, if every sign changes, then it would be odd. If all of them stay the same, it would be even. Correct. Okay. All right. So, oh, I thought I had another example. Let me do one more quick example and then I'll put your homework up here. Okay. So, let's do okay? I want to know if this is an even or odd function. So to do that, I always do f of a negative x. Okay? So negative x squared minus 25. What's negative x squared? Positive x squared minus 25. What type of function would you say this is? Even Steven, because everything stayed the same. So even, everything stays the same. Odd, opposite. Everything's opposite. Good? If neither of those are true, then it is neither. Yes, ma'am. Ooh, we got to be careful on that one. You got to double check because the constant, yeah, that constant messes me up. Okay? That's what messed me up in the last one. Are we good? All right. So you have a whopping 3 homework problems tonight. Sorry, I left that up there. Okay, so problem 1 and 2, you're telling me whether it's even, odd, or neither and proving it algebraically. And then number 3, you're identifying the asymptotes, vertical, horizontal. You get the gist. Yes?